Hi everybody, this is your notes video for Engel addition. There will be some practice problems in another video, but this is just some examples for you. You'll find that Engel addition is very, very similar to segment addition. It's a lot of the same stuff. So if you understood the process of how we did those segment addition problems, you're going to do just fine with these Engel addition problems. If you struggled with that a little bit, you'll get to see it again here. It's a lot of the same strategy. So hopefully, if you didn't get it with segments and didn't make as much sense with segments, hopefully seeing it again with angles, it'll make a little bit more sense. Okay, so just like with segments, the Engel addition postulate is just part plus part equals whole. Whoops. Sorry, my thing keeps moving. Okay, part plus part equals whole. Okay, that's all you're doing, really and truly. Okay, you're taking the two smaller parts of an angle, which are included on the inside. So say here and here, these two parts have to add up to the whole thing, right, which is this on the outside. The fancy way of writing that is AOB, right, which is the first part, the one at the top, this one, plus BOC, which is the smaller part, the one at the bottom here, has to equal AOC, which is the whole angle, okay? Similar to the way that midpoints divide a segment into two equal parts, a bisector divides an angle into two equal parts. So the bisector is the ray in the middle. Now we don't know if the parts are equal unless you see that magic word, the bisector, or for segments if you see the word midpoint. Okay, you have to see those. Otherwise, you don't know for sure that they're equal. And then you have to use this rule, the part plus part equals whole. All right, so let's do some examples, okay, and write some formulas out here, okay? So the actual, go over here. Sorry, I have to do it from over here. Okay, so the actual formula that you're using is when B is in the interior of angle AOC. It's angle AOB plus angle BOC has to equal angle AOC. Okay, and these are your part, and whole, right? Part plus part I type the spaces too fast. It thinks that I'm ending a sentence. Part plus part equals whole. All right, so let's draw what that would look like. Okay, so in my diagram here, oops, got to switch back to drawing. Okay, so I said B is in the interior of AOC. Okay, so the first thing I need to draw is the big angle, which is AOC. So remember, that's A. O has to be the vertex because it's the middle point, or the middle letter here. Okay, AOC. Then they said B is somewhere in the interior. So I'm just going to put it kind of like that, B. And then I'm going to connect O to B right there. Okay, so this is B, right? So in here, I have AOB, which is this part, right? So part. Here's my second part, BOC. And when I add those together, it has to equal this whole thing out here. Let me try writing that again. It's really very badly written. My handwriting is kind of going crazy. It likes to do that when I'm writing with a mouse, okay? So let's do some examples here, okay? So in my first example, I'm telling you that angle AOB is equal to 14, and angle AOC is equal to 37. Okay, when I forgot my degree symbols there. Okay, so for any of these problems, right, when in doubt, draw a picture. Okay, so you have AOC, right? And then you have B in the middle. So they said AOB is 14. So this right here is 14. And then AOC, which is the whole thing, has to equal 37. Okay, and this is what I don't know. I don't know BOC, but I know that 14 plus what I don't know, BOC, has to equal 37, right? So since they gave me the whole thing and one of the parts, I have to subtract, right? So I know that angle BOC, which was my question mark here, has to equal 23 degrees, all right? So that's it. Okay. Again, they get a little bit more challenging, like the algebra part gets a little bit more challenging when you're dealing with expressions, but the process and what you're writing, the process is the same. Okay. So let's try a part plus whole with expressions. Okay. So I'm telling you AOB is equal to 2x, BOC is equal to 3x plus 1, and AOC equals 21. Okay, so let's go ahead and draw the picture. Right? Most of your pictures are going to look the same. That's fine. The picture is just there as a visual representation for you of what's going on. Okay, all right, so I have AOB is 2x, so I'm going to put that inside the angle because that's a part. BOC is 3x plus 1, so I'm going to put that inside BOC, and then the whole thing, AOC, is 21, right? So what I have here is part plus part equals whole, okay? So that's what I'm going to write out. I have my two parts, 2x and 3x plus 1, and then my whole, 21. Right? I'm going to add my parts and set that equal to the whole thing. Okay, so I'm going to combine my like terms on the left-hand side. 2x plus 3x is 5x. So 5x plus 1 equals 21. And then I'm going to use my algebra skills and say, okay, I need to subtract 1 from both sides. So I get 5x equals 20. So then x equals 4, right? Because I just did divided by 5 on both sides, divided by 5, okay? If the question just asks you for x, then you're done, okay? But let's pretend that the question wanted to know what is angle AOB, right? Like I wanted to know how many degrees it was, okay? So I would have to say, take my x value and plug it back in, right? So for AOB, I know that's 2 times x. So wherever I see an x, I'm going to plug in a 4. And so I get 8 degrees, right? I literally just took this value, the x value, and plugged it in right there. All right. Okay, let's do one more example here where this is a bisector, okay, that deals with 2 different expressions, okay? So I'm telling you in this one that angle AOB is 3x plus 17, and angle BOC is equal to 7x minus 15. Now, if you have already watched the segment practice, hopefully you'll know what to do here with this one. So if you want to pause the video and try this on your own, you can. Obviously, you can see it on the left-hand side of the screen. Okay, but I did a problem similar to this in the segment addition practice, okay? So no matter what, we're going to start with a picture, okay? But in this one, I know that the ray OB is a bisector, okay? So what that means is that this angle and this angle have to be congruent. They have to be equal. And this, coincidentally, is how you mark angles as congruent with these little curved marks. If you see it on a line segment, So say you have like a midpoint, like you have A, B, and then C is a midpoint, you'll see congruent marked with a little dash through like this. Obviously not like super relevant to the angle problems, but you know, it's good to know at least so that if you see it in a picture, you'll know what those little dashes, or in this case, the little curves mean. Okay, so I have AOB equals 3x plus 17. Okay, and then BOC is 7x minus 15. Now, this is the only time that you can say those parts are equal, right? And the reason I can do that is because I have this magic word bisect right here. So notice that they didn't give me a whole thing like this out here. I have no idea what that is, but it doesn't really matter because I have two different expressions for my angles that have to be equal to each other. Okay, so I have 3x plus 17 and 7x minus 15. Okay, and since this is a bisector, I can say that those are equal to each other. I only want to do this when I have different expressions for the two parts. If you have that word bisect in there, that magic word bisect, because if they have the same expression, then of course they're going to be equal because they're exactly the same. That won't do you any good. Okay, so you want different expressions for your two parts here if you're dealing with a bisector. All right, so let's go ahead and go through and solve this. So I'm going to add 15 to both sides. So I have 3x plus 32 equals 7x. Right? Again, it doesn't matter what order you add or subtract the numbers and the variables in. I typically do the variables first, but I decided to do the numbers first on this one. Doesn't really matter. Okay, then I get 32 is equal to 4x, and I'm going to divide by 4 on both sides. Divide by 4, divide by 4. So I get that x is equal to 8. Okay, now if you are doing a problem and they just want to know what is the value of x, then you are done right here. But let's say they wanted to know how big is angle AOC. Right, maybe that's what they want to know. Okay, so to do that, let me draw a little line right here. I don't have an expression for AOC, but I do have one for AOB. Okay, so let's figure out what that is first. So AOB would be 3 times, wherever you see an x, you're going to plug in an 8, okay, plus 17. So that's 24 plus 17, which is 41, okay? So if this angle is 41, that means the other part, BOC, also has to be 41. So AOC is 2 of those, 41 times 2, which is 82, okay? So that's just an example for you there. All right, so that is all of the examples for angle addition. If you want to try the practice problems on your own, you have examples to go through pretty much like in this video that I just made for you. There's examples for basically any type of like combination of problems. So you can give those practice problems on these notes a try on your own if you want, or if you want to check them. Right, so try them on your own and then you can check them with the video that comes after this one, the practice problems one. Or if you feel like you need a little bit more practice and being able to see somebody do the problems again with these different numbers to kind of get the hang of it, you can jump right into that practice video and do those along with me. All right, I will see you all in the next one. Bye-bye.